Hello guys, welcome back to my YouTube channel. So today we are going to solve day 27 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So now we are going to solve problem number 1277. Count square submatrices with all ones. We have given m into n matrix of ones and zeros. We have to return how many square submatrices have all ones. Okay, so see this example number 1. Okay, this is a matrix given to us and we are getting output as 15. Okay, so let's check why. So here let's draw this matrix. So this is nothing but 3 into 4 matrix, right? So this is my matrix. Okay, 3 into 4, so 3 number of rows are there. All right, and we have 4 columns. Okay, now let's just fill this matrix. Okay, and we have here 0 and then 3 ones, 0 3 ones, then we have 4 ones in next row, and then after that we have 1 0 and 3 ones. Okay, so this is my matrix. Okay, and this is nothing but row 0, row 1, row 2. Okay, or I can say I is equal to 0, I is equal to 1, and I is equal to 3. Okay, and these are nothing but my columns. So here I can say that this is nothing but j0, j1, j2 and j3. Okay, so now why we are getting output as 15 in this problem? So let's see that. Okay, so this is one valid square, right? So one square, this one, right? This is one valid square, 2, this is one valid square, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, these 10 squares are valid one. Okay, now all these squares are of 1 into 1 size, right? 1 into 1. Okay, now let's see this white color. 1 square, 2 square, 3 square, and this is the fourth square. Okay, so we have 4 squares of 2 into 2 size, right? And we have 1 square of 3 into 3 size, right? 1 square of 3 into 3 size. Okay, so in total how many squares we are getting here? 10 plus 4 plus 1 is nothing but 15. Okay, that is why the output is 15. Okay, 10 squares of side 1, 4 squares of side 2 and 1 square of side 3. That is why output is 15. Okay, so now how we are going to get the output for this problem? Okay, how we are going to solve it? Okay, so now let's see that. So what we are going to do here, let's understand like this. Okay, let's say this is nothing but my dp. Okay, so here this is nothing but dp array. Okay, so we have 4 columns, right? Same number of columns, and we have 3 rows. Okay, and here let's write same. I is equal to 0, I is equal to 1 and I is equal to 2. Okay, and here j is equal to 0, here j is equal to 1, here j is equal to 2 here, and j is equal to 3 here. Okay, so here at this box we have 0. Okay, so there is no square that is ending at this particular cell, right? So here I am going to write 0 only. Okay, now here, see here there is just one square. Okay, which is ending at this particular cell. Okay, square is what? Square is having same sides. Okay, same length and same width, right? So only one square we can get at this particular cell. Okay, same way only once a cell we can form a square here. Only one cell can form a square. Okay, because in top there is no other cell. Okay, we don't have the option to create something like this. Okay, so only single cell can be utilized. So here what I'm doing, the cell in I have to write the number of squares which can be formed in this cell. Okay, which are ending at this particular cell. So only one, right? So here I'm going to just fill one, here one. Okay, one. So I'm going to write if my I is equal to 0 or my j value is equal to 0, then in that case simply fill my dp array with one value. Okay, if okay, there is one condition, one more condition here. If that particular cell value in my matrix is not equal to 0. Okay, if that particular cell value is not equal to 0, in that case just fill it 1. So here I is equal to 0, so here I am filling 0 and 1 1 1 wherever 1. Okay, same way in this column j is equal to 0 column, right? I am filling here 0, and here I am going to fill 1, and here I am going to fill 0 because 0 is there. Okay, so clear, right? So I'm feeling what the number of squares which are ending at this particular cell. So definitely if this is top one, so only we can form one square only. Number of squares which are ending at this particular cell, only one. Okay, because it's a corner now, so that's what. Okay, now how I'm going to fill these values? Okay, middle values. Okay, so I'm going to fill middle values like this. Okay, so here see, I want to check how many squares which are ending at this particular cell. Number of squares which are ending at this particular cell. Okay, this is what I need to see. Okay, so here if you see diagrammatically, so here only one, right? Because in top there is one, in this side there is one, and in diagonally it's 0. Okay, so we can't form this. Okay, so this is how it looks like, right? We have 0 here, 1 here, 1 here, and 1 here. So only one square we can form. We can't form a square of 2 into 2 side at this particular cell, right? We have two options. Okay, so here something like this. Okay, it is like this. We have two options here, whether we can form this square or we can form this square. Okay, two options we have, but we can form only one here because here it is 1, and we can't form this 2 into 2 because here it is 0, right? So we can only form this one. Okay, so here I'm going to write 1. Okay, right? Now how I'm going to write 1? Okay, I'm writing 1. I know that it should be 1, but there is a simple way to calculate this one. So I'm saying just get the minimum of these three. 1, here it's 0, and here it's 1. What is the minimum of these? Minimum of these is 0. Okay, and in this minimum just add 1 if that particular cell value is 1. Okay, so if that particular cell value is 1, only then I am updating it. Okay, otherwise I'm going to keep it 0 only. So here there was some value, there was 1 here. Okay, so in that case I have to check. So 1 0 1, minimum is 0, in that minimum 0 add 1. Okay, this is done. Now I have to find the number of squares which are ending at this particular cell. Okay, so here if you see here, so we can form here we can form this square. Okay, and we can form this square. Total two squares we can form, right? Here. Okay, this is like this now. Let me draw it again here. Okay, so here 0 1 1 1 1 1 1 1 0 1 1 1. Okay, now I'm talking about this particular square. So okay, so at this particular cell how many squares we can form? We can form this square, and we can also form this square. Okay, so total 2, right? This is what we know. Now how we are going to fill this? Here minimum of this and this. What is minimum among them? 1. In 1 add 1, so we will get 2 here. I'm going to write 2 here. Simple. Okay, now see here. Here what is the output? Number of squares which are ending at this particular cell. This is the one square, and this is one square. Only 2, right? Only 2. Which 2? This. Okay, let me use some other pen. Here this one and this one. Okay, this is not a square. Okay, this is a rectangle, right? So only 2 squares we can form. Okay, so how I'm going to fill this? Minimum of these, minimum of 2, 1 and 1. Minimum among them is 1. In that one add 1, I will get 2 here. Okay, this is done. Okay, now I have to fill this. Okay, so here out of these three, which is minimum? 0 is minimum. In that 0 add 1. Okay, so we are getting 1. So let's check if 1 is the only possible case. Yes, only this square we can form, right? Which are ending at this particular cell. Ending means bottom this corner. Okay, this corner, bottom corner, bottom right corner. Okay, that's simple means of end. Okay, and this is the ending point. Okay, okay, now here I filled 1. Here out of these three, which is minimum? 1 is minimum. in one add 2. So let's check if 2 is the case. Okay, this is one square that we can form, and this is one more square that we can form. Okay, two squares. Okay, we are good. Now here, this two and this two, which is minimum? 2 is minimum. Okay, so in this two, just add 1, we will get 3. So here it's saying 3. Okay, so let's check if 3 is the case. Okay, so here one square is this one square is this one, and one square is this one, which are ending at this particular cell. Total 3. So we are correct, right? 3. Okay, so in the end, what we need to do? In the end, just do the summation. 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 1 plus 2 plus 3, we will get 15. Okay, 3 4 5 6 7 8 9 10 11 12 13 14 15, and that's our output. Okay, so this is what we need to do. Okay, simple thing, simple thing. Okay, so now let's write the code for this same thing. Okay, I hope that you guys are clear. Okay, I'm not going to make this video lengthy, so that is why I'm just going to solve this using a DP bottom-up approach. So if you guys need the solution for recursive top-down approach, then please write it in comment section. I will paste the solution for that part as well. Okay, recursive approach, but let's understand it with DP only. Okay, first int m is equal to number of rows, so matrix dot length, and n is nothing but number of columns I have. So just pick one row and just calculate the length of that particular row, so it will give me the number of columns. Okay, create one DP array, and DP size, let's keep it same as my matrix m into n. Okay, initially all the values in DP is initialized to 0, right? Initially. Okay, so what we need to do now, count. Okay, count is equal to 0. So here I'm going to run one loop. Okay, int I is equal to 0, I is less than m I plus plus, for int j is equal to 0, j is less than n j plus plus, and here inside this, only if my matrix of I of j is 1, only in that case I need to update the values, right? Okay, only in that case. Otherwise we have to just keep it as 0 only. Okay, our DP. So here inside this boundary conditions, if I is equal to 0 or if my j is equal to 0, like simply means that these are the corner cases. Okay, so all the cells which are at this particular position will only form one square only, always. Okay, if the matrix of I of j value is 1, right? So only one is the possibility. So here I'm going to write 1. Okay, edge case, first row or first column, that's it. And here in the else part, my DP of I of j, I'm going to update it as same thing that I have explained here. Same thing, we have to check tops, left, and diagonally top 3 space. Okay, for the particular cell. Okay, so this is a possibility. So okay, so here what I'm going to write, so here minimum, we need to find the minimum. Okay, so here math dot min. Okay, now here inside this DP of I minus 1. Okay, simply means that I am checking top one, top row. Okay, I minus 1 j. Okay, this. Okay, this is one thing here. Okay, DP of j, I need to write it like this now, j. Okay, this, or DP of left side. So for left, row will remain same, and I have to subtract the column, so j minus 1. Okay, this minimum. Okay, and I also need to check the minimum with the diagonal one. Okay, I'm checking minimum between these two. I have to check this one as well. So what I have to do, so here just do one thing now. Here create one more math.min. Okay, and here give dp of I minus 1. Okay, diagonally top we need to move I minus 1, so j will also be decremented. Okay, so this, and in this I have to add 1. Okay, because here if this particular cell is 1, only then I am checking, so I have to include this. Okay, as a square, so here I have to write 1. Okay, this is done. And here just update my count is equal to count plus dp of I of j. That's it. That's it. Okay, so easy. Now just return count. So this is where my for loop ends. So here just write return count. Okay, let's run it. So see, our solution is accepted, right? Now let's submit it. So you guys can try to write the recursive approach as well. Okay, using the same code, using a dp code, you can just try solve it in using a recursive approach. And if you are done, then please paste the solution in comment section. And if you want, I can also paste the solution in comment section. Okay, just let me know in the comment section. So time complexity is going to be of m into n. Okay, we are running this m into n times. And I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.